Welcome to our course on the principles of shear slitting. We offer this course in support of our customers and their employees. Those completing this course will become familiar with the basic terminology and concepts of shear slitting. We will cover the following topics. 1. Slit cutting methods. 2. Principles of setting up for shear slitting. And 3. Common shear slitting problems. At the end of this course, learners will be able to identify components of shear slitting systems, set up for proper slitter operation, plan for maintenance of slitter systems, and identify and troubleshoot common shear slitting problems.
There exists in manufacturing today 3 different types of web separation: burst slitting, score or crush cut slitting, and shear slitting. The first process we will discuss today is burst slitting. Burst slitting uses only one knife to perform the work. The cutting tips are razor sharp and come in both round or circular configurations or in the regular rectangular razor blade configuration. To increase the productivity of a razor burst slit setup, consider raising the quality of material that your blade is made of from D2 to M2, or you may even select a carbide or ceramic material for your razor blades to increase their run life. Burst slitting has its place in the conversion of various types of paper, film, and foil products, as well as some non-woven materials. Score cutting. Score cutting uses a top knife and a hardened steel anvil roll in the setup. The score knife has to have a radius on the cutting tip. The amount of radius on the tip can vary, and its size depends upon the type of material you are cutting. This chart shows recommended radius sizes for you to test cut with. You can download this chart from our resources section on our website. As mentioned, the tip radius is very important on the score knife. Too small a radius and the tip will roll over and your blade will fail prematurely. Too much radius, and the tip will not penetrate what you are trying to cut. If your tip does not pierce the material web, you may also try changing the angle of attack on your cutting blades to a more acute angle. Make them sharper. Another important thing to remember in score slitting is to keep your bottom anvil clear of grooves. Score cutting will wear a groove naturally in the sleeves over time as you have steel-on-steel contact. When that happens, simply move your cutting tip to another part of the sleeve. The third type of web separation is shear slitting, which is what we will discuss the rest of this presentation. In shear slitting, you have a top and bottom slitter. These two blades rotate together to shear slit your web. The shear slit dynamic is the same as you see in a pair of scissors. The setup for a rotary shear slit is more difficult and requires much more exactitude than a burst or score slit. Shear slitting can be broken down further into 2 types: tangent or kiss shear slitting and wrap shear slitting. The decision to use one over the other depends upon the material you are cutting. If the material is delicate or inflexible, you will see the tangent system in use. If your web is flexible and able to withstand the pressures of the wrap around the bottom knives, then you will see the wrap method in use. Because of the wrap around the bottom knives, the web is propelled more efficiently and higher slitting speeds can be attained. As mentioned, the dynamics of a rotary shear used in paper, film, or foil web separation is very similar to the dynamics that exist in a pair of household scissors. In order to make the scissor cut, pressure must be applied to the handle to make the cutting edges come together at that one intersecting cut point. This point is never at the tip of the scissor, but deeper back in the throat of the scissors. The same elements that enable the scissors to cut, where the two cutting edges come together optimally, are necessary and must exist in any efficient shear slit setup. Before we leave this scissor example, I want to cover the overspeeding of your bottom knives in any shear setup. Because your top knives are powered by your bottom knives, and because of the fact that the slitting process itself will have a slowing effect on your top knives, you need to overspeed your bottom knives by a factor of 3 to 5% to prevent a buckling or a backup of the incoming web being cut. In any shear slitting setup, there are 4 principles that must be present in your setup for optimal shear cutting to occur. Number 1, cant angle or toe in. Number 2, side load pressure between your top and bottom knives. Number 3, the amount of blade overlap between your top and bottom knives. Number 4, the rake angle of your top knife. The first one we will discuss is cant angle. It is also sometimes referred to as toe in. You want in your setup a positive cant angle. Cant angle will establish the exact cut point between the top and bottom knives. In this setup, you will have steel running against steel, and because of this, your blades are going to dull no matter what. There may be a tendency during the setup, if problems occur, to increase the cant angle to solve a cutting problem. Avoid this temptation as it will dull your knives prematurely and necessitate a reinstall of your top and bottom knives. Remember, you have steel running against steel. Slitting machines and holder manufacturers should have precise instructions on what to set your top knife holder cant angle to. Many times this is built into your holder, but a good way to double check the cant angle in your holder is by using a feeler gauge and a flashlight to see what the cant angle actually is on your top knife in relation to the bottom knife. We have listed some common cant angle and dimensional information for you to test top knife holder setups with. Who knows? Even if your holder has a preset built into it for cant angle, something may have moved. It's always good to double check. Cant angle or toe in is always a good place to start with when you are trying to troubleshoot while your blades are dulling quickly and you're not getting the run life you anticipate. Side loading pressure is simply the amount of pounds per square inch of pressure your top knife is pushing against your bottom knife. The least amount of pressure necessary to get your cut to work is the amount to be used. It may take more pounds of side loading pressure than your system calls for. If this is the case, then you are compensating for worn bolts, slides, gibs, gears, bearing seats, and the like. This is one way to know that your holder delivery system needs to be rebuilt. It is always good to check your side pressure with a Hunter force gauge to make sure you do not have excessive pressure on your cutting knives. Note, excessive side pressure will cause your blades to dull prematurely. Check machine manual for the correct setting, but typically most pneumatic slitter assemblies will have side loading pressures of anywhere from 2 to 7 pounds, not to vary by more than 1/2 pound per recommended pressure. In shear slitting, your knives overlap. The amount of overlap depends upon your system and what material is being cut. In tangent slitting, there is only one possible cut point designed into the system. That cut point is the topmost tangent point of your bottom slitter. In wrap slitting, your cut point can be anywhere along the wrap area. In tangent slitting, to set and reset your top knife to the exact cut point, a chord angle gauge should be used. This will give you exact and repeatable settings to the cut point. For more chord set point gauges, go to pages 10 and 11 in our training manual or go to the resource section of our website. Rake angle on the top knife enables the inside face of your top knife to fit the same angle on your bottom knife. If your bottom knife has a 3-degree cutting angle on it, then the inside face of your top knife needs to have a 3-degree angle on it for it to fit and connect to the correct cut point that your system was designed to deliver. There are slitting machines in service today that require the shifting of the entire top knife bar to achieve the cant angle. As you can see by the diagram, the average cant angle on this type system averages out to be neutral or zero. The OD, or outer diameter, of this type system is usually around 4 inches or 100 millimeters. So the extremes are not that detrimental to the overlap and cant angle connection. When you have a number of slits happening across your web, forces will build up on your web caused by the number of cuts taking place. To make their interference in the web less intrusive, minimizing the side forces created by multiple cuts is achieved by putting a long secondary bevel or angle on your top knife. As you can see in the diagram, this relieves pressure with the backside of your top knife sanding away your web as it is cut. The dynamics of the shear slitting process will always cause blades dulling because when your setup is correct, you have steel against steel. Minimum side pressure, you'll have minimum dulling. Minimum cant angle, you will have minimal dulling. But the abrasiveness of your material will cause your blades to dull also. Sometimes corrosive environments cause the breakdown of the cutting edges. There are a few other points to consider in your setup when you're discussing and considering how to optimize slitting time. Axial runout of your knives is a side-to-side wobble in either the top knife or the bottom knife. Axial runout can be caused by a number of factors: warped blade, bent shaft, worn bearings, debris under your mounting hubs or holder. You can see a list of things that commonly cause this to happen on page 17. Radial runout is an out-of-round condition displayed by knives during operation. Radial runout is caused by a number of factors. You could cause it with a bent slitter knife shaft, blades manufactured improperly, blades that are laying out of flat, knife blades running faster than the critical speed or machine design speed. Bores of knives that are too loose on the arbor as they mount will give you radial runout. Radial and axial runout, as well as improper cant angle, depth of cut, side load pressure, and rake angle settings, will cause premature failure of your web separation efforts. You must review your machine manual to maintain required settings in all these areas. The surface finish of a knife will affect the surface finish of your cut material. Rougher surface finishes on a blade act as a sanding agent against the web you are slitting, causing frayed, rough, or jagged edges. Critical surfaces should be polished. Sometimes in cut quality questions, the machine and/or the blades are not the culprit. Sometimes the trim system needs to be scrutinized. You must have your trim supported under tension and horizontal during exit. Trim must be drawn away straight ahead and in line with the web to prevent tearing. Trim must not be permitted to flutter at the slit point. Trim must not be pulled directly off the slit point, as this will cause tearing. Trim must not be forced into abrupt changes of direction. Trim suction speed should match or exceed the web speed. Fluttering trim will aggravate break-off tendencies. Avoid abrupt corners on your trim pickup systems. Standard fatigue wear lines on both the top and bottom cutting knives should be established for maintenance purposes. A general rule of thumb is 12 thousandths to 15 thousandths wide wear band on your top and bottom knives. Once your machinery is in good running order and your system properly set in regard to all the items covered herein, The only way to improve your runtime is to improve the material that your blade is made of. As you can see in this chart, quality, expense, and wearability increases from left to right. Starting in the far left-hand column, your alloy steels are your low entry point level to material selection of slitter knives. Moving all the way to the right, you can select carbide or powdered metal products to increase your run life. Our specialists will be happy to recommend the cutting edge best suited for your requirements. We have an operator's checklist and slit knife setup checklist. This checklist, as well as other operator resources, are available for download on our website.